Hey, Topping Your Life's Math and History, and we're gonna take a look at the different types of intersections. So, in the previous video, we have been taking a look at what happens when you have two y or slope-intercept form equations, and what we did to them was make them intersect at a point. But there's just more than one answer than intersecting at one point. There are actually many other ways to answer those kind of problems. There are three types, so let's move on to the first one. So, with the first one, we have two equations, y equals 3x plus 10 and y equals 2x minus 5. Let's graph those on a graph. So, when we had the two lines intersect each other on the graph, we got negative 35 as where the point intersects. So let's see what happens when we insert something in for x and then get to our y. So what we're going to do is do it algebraically. What we're going to do is, since the 2 equal y, we have 3x plus 10 is going to equal 2x minus f by 5. When you get x isolated and find out what x is, you plug in that x for the formulas or the slope-intercept forms and see if they intersect at negative 35. So let's get started. We have 3x plus 10 equals 2x minus 5. So what I'm going to do is subtract this by 2x, subtract that by 2x, we get just x plus 10 equals negative 5. So after that, we need to get that 10 on the other side. So we have minus that by 10 and minus this by 10. So x is going to become a negative 15. And we insert that into here and plug them in. So negative 15. 3 multiplied by negative 15 is negative 45. Plus 10, that is going to be negative 35. So that is checked. The bottom one, let's try that. Negative 15 multiplied by 2 will become a negative 30. Oh, and yeah, a negative multiplied by a positive will become a negative. So, negative 30 minus that by 5 is going to become negative 35. So that's also checked. So we have proved that these two will intersect at negative 35 because they equal each other. And this kind of answer that we found out is called a normal answer. Because a normal answer means that there are just two lines intersecting, but at only one point in the math part, or one point in the game. So pretty much, a normal answer only has to have one intersection. Let's move on to the next one. So, the next type of answer that we're going to get for this one is a little bit strange because we have y as the same, our slope as 4 as the same, x as the same, but the only difference is going to be the 1 and the 3. So they start at different places. Let's see what happens when we graph the two. So, in the two lines that never intersect each other, those are called parallel lines. And let's see why and prove why those are parallel by trying to do it algebraically and see what happens if we try to find where do the two lines intersect, which they never do. So we have 4x plus 1 is going to be equal to 4x plus 3. And what you might be thinking is, why don't we subtract this side by 1 and subtract that side by 1? So we have 4x equals 4x plus 2. Right away, you can say that this doesn't make any sense. Huh? How does 4x is the same thing as 4x plus 2? That makes totally no sense. So we can say that this kind of answer is called no solution. The reason why is they never intersect each other. And the two slope-intercept form equations we had have the same slope but different y-intercepts or different starting points. So that's why this kind of answer is called no solution. You can know right away without doing the math if you have the same slope but different y-intercepts. So basically, you can get by this super fast. Let's look at the very last type of answer we can get while trying to find the lines that intersect each other.
It's as bad as it looks, Star Fox. We need your help.
Come on, let's give our boy some support. Hey, Fox, you made it! Bill, is that you? It's been a while. We've got a fleet to save if you're interested.
So, the last one we're going to look at is basically the same thing as no solution, but the opposite. Let's see what happens when we try to graph these equations. That is very strange. There are no intersections, but the graph only shows one slope? Let's see what happens when we try to do that algebraically and see if it actually intersects somewhere. So, we have 3 over 6x plus 7 is going to be the same thing as 1 over 2x plus 7. What the first thing you might want to do is subtract the 7's from each other. So minus that by 7, minus that by 7. We have 3 over 6x is the same thing as 1 over 2x. But wait, 3 over 6x or 3/6x is going to be the same thing as 1/2 of x. So pretty much this is going to be the same. With the equation we had above, we didn't have to do any math because this right here is technically the same thing as this right here. Anything that you insert in for x will always have the same answers, like 10 equals 10, 1 equals 1, 1,000 equals 1,000, or 7 equals 7, or 7 equal each other. So basically, we can say that there are an infinite amount of answers. Because anything you input in for x will always be the exact same thing. You can quickly identify those kind of problems and answers when you have the same slope and the same y-intercept or starting position. So these two are technically the same. And if you try to graph two of these equations, you will only get one giant slope.
We're readying our main cannon. Get out of the line of fire.
Cannon ready. Countdown. 3, 2, 1.
Fire!
What? How?
We didn't even scratch it. That's some shield.
Is that the best you can do? Then you'll really enjoy this! All crew, brace for impact! We've been hit! Evasive maneuver!
So basically, these two are exactly the same. M is called an infinite number of solutions. So that no solution and normal answers are all the different types of intersections that you can have with two lines. Thank you for watching Tao Ping Airlines Math Industry. Like and subscribe.